Hare Krishna. Hope you are doing well. Let's get started with this expectation oriented question. We will be needing the prerequisite on Poisson distribution and a very unique thing, attention to the way expectation is calculated for this distribution. We'll see why. Okay, we need to find the expectation of this function of the random variable Poisson distribution. Now, this would very well translate to this because this part is captured over here, and this is the PMF, probability mass function part for each of the point 0 to infinity, and there is a summation. Looks complicated, but if we inspect closely, now this thing we must know that e to the power lambda can be expressed as this summation. And then, in light of this, when we look at this again, we do see that this is cancelling out and making this x minus 1 factorial, right? And again, if lambda x can be written as lambda x minus 1, then that lambda can be taken out. The motivation is we know the structure already. Can this apparently complicated structure be reduced to this known structure like this? That is the intuition, that when given a complicated computation, try to transform it into a known computation. And this is why I really like this sum. It seems slightly complicated, but to solve it, you just need to pay attention to the aspects of the computation of Poisson expectation. You don't need much actually. It's a little smart work that we have to do. I really like these kind of sums. Now, one more thing to notice is that, which could be a pitfall, when we are taking this, taking lambda common, taking reducing this to x minus 1 factorial, we also need to make this minus 1 as minus 1 multiplied by minus 1 x to the power minus 1. The reason is we are bringing it into this form where the summation starts from x equal to 1. So everything over here should be of the form x minus 1, x minus 1, x minus 1, because then this would effectively become x minus 1 equal to 0 summation to infinity, and this x minus 1 will become a new variable in itself. So this would be like summation z equal to 0 to infinity minus 1 to the power z lambda z and z factorial minus uh, 1 and lambda can be taken common. Now, while doing this thing which I was talking about, the minus 1 comes out and stays there. So this minus 1 lambda and e to the power minus lambda, they come out, and this thing gets transformed to e to the power minus lambda. The entire pitfall could be centered around this minus 1, because if we don't take this minus 1 out appropriately, everything was right, but because of this negative sign, you could get to the wrong answer. Here the right answer is this one. That was it. Take care. Hare Krishna.